So knowing everything we know, how come electricity is able to go so fast? Well, let's take a look at this example I created. So how can your friends receive your text so fast? So I looked up online that the speed of electricity is about this fast over here. So as a number, that is 299 billion meters per second. So if we were to have electricity go along one 12-gauge copper wire, it would travel about that fast per second. So every single second, it's able to go that fast. So if you were to send a message from you who's in New York over to your friend who's in Russia, hey, what's up? You got some polar bears? And this message would travel from right here to right here. So the question is, if it is 5,369 miles, then how long would that take to actually go there? So here's a little pocket math to investigate this. So first thing we need to know is how many meters is this, because we currently have this in miles, and it told us that it goes this many meters per second. So in order to turn this to meters, we're going to find out the conversion, which is 1 mile is 1,609 meters. So we simply multiply the number of miles that we have by the number of meters, and we get that it's 8,640,568 meters. So we're going to take that number, and that is the distance over here, 8,640,568 meters. So that is the distance from New York to Russia. So how fast can we send a text, and would it go from ourselves to our friend in Russia? Well, if we knew that the speed is able to be traveled over here at a speed of 299, then we can put this number over here as a ratio, as their denominator, and we're going to put the number of meters that we're trying to test to see how fast it would go, and we're going to create an equal proportion. So we know that we go this fast in 1 second, so we want to know how far does this go in how many seconds. So we're going to end up cross-multiplying, so we get this number over here multiplied by 1, which we get over here, and then we get this number multiplied by x, so we get this equation right over here. So after cross-multiplying, we want to solve for x, which is our fun guy right over here. So we're going to divide by 299, this number right over here. We divide by the same number, and we end up getting that x is equal to about 0.043032. And this is rounded, obviously, but what that tells us is if we were to turn this into a percent, which is just multiply by 100, or move the decimal place 2 places, it is going to be pretty darn fast. So we're going to get this in about 1/20th of a second. So our text message can get it from New York all the way over to Russia in 1/20th of a second. So if we can do it that fast from here to Russia, how fast would it be able to travel all the way around the entire world and get back to the same spot? Well, the Earth is about 25,000 miles. And when I say 25,000 miles, this is its circumference. So its distance from one spot all the way around the world back into the same spot is 25,000 miles. So if we could assume that 5,000 miles, which is really close to what we got, we had that it was 5,369, so we're rounding a little bit. So 5,000 miles was 1/20th of a second, which is just what we found. Then we could simply look at the total circumference, which in this case is going to be 25,000, and we would be able to say, okay, well, if we multiply 5,000 by 5, we get 25,000. So if we were to similarly, proportionally multiply 1/20th of a second by 5, we'd get 1/4 of a second. So using that napkin math, we could find that it takes about 0.25 seconds for electricity to travel all the way around the world. So knowing that electricity can travel all the way around the world and text messages travel over Wi-Fi, which is using electricity, it makes sense why we're able to get messages so fast, because even if you were to send a message all the way around the world, you would get it in only 0.25 seconds approximately. So pretty cool.